Volkswagen's TSI engines, a spark of genius that has led to an impressive success story. And it continues with the 1.2-litre TSI engine with 77 kilowatts. High-torque engines with extremely low fuel consumption and minimal carbon dioxide emissions. It was by realizing this formula for success that the technological innovation from Wolfsburg achieved worldwide recognition in next to no time. The 1.2-litre TSI engine with its output of 77 kilowatts now makes Volkswagen's technological revolution available for the entire range of Polo and Golf-class vehicles. In developing the 1.2-litre TSI from the small but powerful engine series EA111, Volkswagen's engineers focused rigorously on reducing frictional losses and on the use of modern lightweight materials. The result was a new weight-optimized aluminium crankcase and a totally new combustion system. TSI technology design, which combines outstanding performance with fuel efficiency. The key innovations in detail. The new aluminium die-cast crankcase with innovative grey cast iron liners and an integrated oil separator system, for the first time also in a TSI engine by Volkswagen. A revised timing chain case concept with two removable covers made of die-cast magnesium and plastic. The advantages: a marked reduction in weight, low system cost and low maintenance. Volkswagen's developers were able to minimize the engine's frictional losses by means of a range of innovative and intelligently complementary measures. In designing the new crankshaft, they resorted to the latest simulation technologies. This allowed the diameter of the main and big end bearings to be reduced to 42 millimeters. The result? Only minimal friction in the bearings. The optimal geometry and the decision to use steel led to a flexurally resistant crankshaft with excellent acoustic properties. The simplified 2V valve train with a single camshaft and small camshaft bearings permits a further reduction in friction, whilst ensuring optimal breathing efficiency for the small TSI engine. Developing the world's first entirely new 2V direct injection combustion process with the typical response of a TSI posed a special challenge to Volkswagen's engineers. First of all, they had to model the optimum swirl duct for an efficient swirl combustion process. Starting with a basic duct, 6 geometrical parameters of the intake port were continuously varied until the ideal values had been determined in terms of fuel economy, smooth running, and emissions. The high-pressure injection valve, crucial for creating the ideal mixture formation. The latest generation of the multi-hole injector, with improved dynamics and more accurate volume control, ensures virtually perfect spray geometry while minimizing the injection time. An innovative engine like the 1.2-litre TSI requires its designers to come up with innovative solutions in all areas, not least when it comes to the charging process. The demands for the thermodynamics of the turbocharger are particularly high for the smallest in Volkswagen's TSI family, because of the ambitious fuel economy and performance targets. At the turbine end, the developers opted for a mixed flow turbine with a low moment of inertia and high dynamic range of engine speeds. The single-piece exhaust manifold was optimized for minimum pressure loss and maximum utilization of the exhaust energy. On the engine's intake side, the water-operated charge air cooler, already successfully used in the 90 kilowatt TSI, has been employed once again. Reducing the volume of the charging device has further improved the turbocharger's responsiveness. In addition, an electric wastegate controller was developed for the first ever use in the high-volume series production of a TSI, in the 1.2-litre 77 kilowatt engine. Its key advantages are that no matter what speed the engine is running at, the wastegate flap can be set to any position. thus avoiding back pressure in the exhaust system and charge exchange losses. Even when accelerating at full power, the wastegate can be kept securely shut, meaning that the charge pressure can be built up considerably faster. The outlined set of technical innovations has allowed Volkswagen's designers to create a powerful engine with a high fuel economy and low carbon dioxide emissions. Compared with the conventional MPI engine, the outstanding agility and liveliness of this engine are particularly striking. A high specific torque is available, even at just 1500 RPM, and this can be maintained over a wide range of engine speeds. In view of the increasingly heated discussions about CO2 emissions, the reduction in carbon dioxide emissions by up to 50 grams per kilometre travelled is particularly satisfactory. What is more, this reduction in emissions has been achieved without forfeiting performance. On the contrary, as is impressively demonstrated by the Performance Feel Index developed by Volkswagen to assess the driving experience objectively. Volkswagen thus lives up to its responsibility for continually developing environmentally friendly engines. The fuel efficiency of the 1.2-litre TSI engine is something to be proud of. The Polo, with manual transmission, returns a fuel consumption of 5.5 litres per 100 kilometres, for instance, and the models fitted with Volkswagen's 7-gear DSG transmission even manage 5.4 litres per 100 kilometres. The 1.2-litre TSI engine with 77 kilowatts. A successful innovation by Volkswagen, which offers customers all the fun of driving and economy, along with excellent emission and fuel efficiency levels. Drawing on their extensive experience in building and developing highly charged, small displacement engines, Volkswagen's engineers have created an engine that is convincing in every way. Smooth running, agile, lively and powerful, whether out on the highway, in the mountains or in town. And at the same time, economical and environmentally friendly. The 77 kilowatt 1.2-litre TSI, an innovative engine for the needs and demands of tomorrow, by Volkswagen, of course.